Welcome to lesson 58, where we'll look at rate problems in our two-step equation form. So things to look out for: how we're using solve to set up our plan and process, how we are identifying the rate and the one-time initial cost. So in other words, really watch and think about how I'm figuring out what the A is for the rate and what the B is for our equation, and then how I use that to create our equation in a very familiar form. We'll start with the first problem. If Elizabeth gets $5 per hour to babysit plus $4 extra for putting the children to bed, write a formula that can be used to find the amount A she makes after working H hours. So pretty much all they're asking us to do is to write the equation for how much A is when she babysits with H hours. This is what we know so far. We know that the rate is $5 an hour. We know that she gets $4 extra. So just from there, we can pretty much figure out what our A is and what our B is in the problem. And we know that A is supposed to be the final amount and H represents the number of hours. So here is my plan. I'm going to write that equation that represents the scenario in this form. And in this case, I do not have to solve. So that's the thing. They didn't ask us to solve, and we can't solve for anything in this problem because we have two unknown variables. We don't know how much he makes at the end because we don't know how many hours. So we're only going to write the equation with A and H in it. Hit pause so you can jot this down in your notes. All right, let's put our plan to action, and we're going to try and put this entire context, this problem, into our form AX plus B equals C. And we know the AX is going to represent some rates in a problem. So what we already know is, we know Elizabeth is getting $5 per hour, and we know that's our rate. So we're going to represent that as 5H. So since that's the number of hours. And what's constant in the problem? What is not changing? And that's the additional $4 that the babysitter is getting. So that's staying constant. And the C is going to be how much she makes altogether. In the context of this problem, we want to find a formula to find the amount A she makes after working H hours. So A, which stands for the amount after H hours. And that's it. That's all we had to do for this problem, was just to take the context of it and write it into an equation. And that form that we've been doing for two steps equations, AX plus B equals C, fits perfectly with rates. We just have to identify what is the rate in the problem. That is our AX. And what is the constant in the problem? That is our B. And ultimately it totals into something C. So hit pause so you can jot this one down into your notes, and we're going to get more practice. Here's our second problem. If Matthew gets $10 per hour to mow the lawn and $8 extra for raking up clippings, write a formula that can be used to determine how much money M he would make after working H hours. So again, we're just writing the equation for M depending on how many hours he works H. We know the rate. We know how much he gets paid extra, so there's our constant, but we do not know the final amount because we do not know the number of hours. So we have two unknown here. So my plan is only to write an equation that represents the scenario, but we're going to have two unknowns in this problem. So we're not going to continue solving and working through an actual problem because we just don't have enough information. But hit pause so you can jot this plan out and see how I create the equation. Okay, we know the plan at this point. We want to write our equation in AX plus B equals C form. So let's distinguish what are the terms and which terms represent a rate. And we're going to look at this first part here. We know that he makes $10 per hour. That is our rate. So 10H. And that represents the $10 per hour. And we know that our constant in there is the extra $8 he makes for raking up the clippings. And once we add up the clippings plus how many hours altogether, that is equal to how much money he earns. So there we have it. I'm going to just annotate a little bit more. We have our rate, we have our constant, and we have our total. And that is our equation from the context of this problem. This is going to be really good practice so that when we see a problem like this, we can put it into a form we recognize and solve for any unknown. Hit pause so you can jot this down into your notes.